All right, a little quick physics tutorial. Boom. So we have distance over time equals velocity. Velocity over time equals acceleration. So acceleration is going to be distance over time, because that's because you're moving faster in time over time. So that's why acceleration is called meters per second squared. We measure things in meters in physics. So we're going to take that here. This v actually is a change in v, and that v is also a change in v, and that's also a change in t. So a change in velocity or change in time is represented by that little triangle right there. And we will notate either v2 minus v1 over t2 minus t1, and you may recognize that from your point slope formula, where the slope equals m equals y2 minus y1 over x2 over x1. Something like that. You go and check your notes. So from that equation, we're going to do some basic movement around and rearranging the equation. We're going to multiply both sides by t. This t can say it's t. We're going to multiply both sides by t. Then have at over there. Then we're going to divide both sides by a. And then boom, we have v2 divided minus v1 divided by a equals t. I'm just going to go really fast through this, all right, as fast as I can. Then we have v over here. So this v is going to be that second equation we just came up with. So this is going to give you the final velocity. Final velocity equals final initial velocity plus acceleration over time. Acceleration times time. You go back over here, you'll see acceleration times time equals velocity. So this is just another acceleration statement, but it's also a velocity statement. So when you see AT, just also think of velocity. But we're going to write AT here because we're actually going to be speaking in the units of change. Change in what? Change in velocity over time. So you're going to be changing this meter, increasing the amount of meters you're going in time. So that brings us to the second equation. There's something to remember here also. This little thing right here, if you don't know how to take the average is the sum of whatever things that's being added. So you got 3 bags of chips, 4 bags of chips, and 7 bags of chips. You're going to add up all those bags of chips and divide it by 3. So over here we have velocity 1 and velocity 2 because we have the initial velocity and the second velocity. And we're going to divide that by 2. So this term right here is the average velocity statement. We're going to take that average velocity statement and we're just going to multiply that by time. Boom. So now we have distance times 1/2 VF plus VI times T equals distance. And you should know that we're putting it on the little radical equation, right there, and that means division. So if I have to explain that to you, watch another video. Boom. Then we're going from there. Then we're going to take this equation here, right? And we're going to put this equation into that equation. So what we're going to do is take that V final and replace it with this V initial plus AT. And now we're going to replace it in there. So we're going to have 1/2 V initial plus AT plus V initial times T. So then we're going to use the distributive property, and that's going to end us up with having 1/2. You see that 1/2 is going to be there. That 1/2 is going to go move over, and we're going to have VT here. So we're going to have we have 2 VTs, VIs right there. VI initial, VI initial. So we're going to have 2 of those there. We have that 1/2 that's right there. So that 1/2 right there, we're going to bring that over there, and that's 2. So we're going to have 2 VI because there's 2 VIs. So we have 2 VI, but that 2 VI is going to get canceled with that 1/2 right there. So that's going to cancel out that VI. So VI is going to be by itself because that 2 is going to get off of that right there. Boom. So we have 2 VIs, but that 2 VI times 1/2 is going to cancel that, and it's going to left with V right there, VI. Then we're going to have T, distributive property. Boom. Boom. We're multiplying that T times that one. Boom, right there. And let me come over here so it's easier for you to see. Boom. We're going to multiply that T times that 2 VI. So that's going to be 2 VIT, but we had that 1/2 times the 2 VI. So it's going to get rid of that VI. So this is going to be VT. Then we're going to do the other side of the distributive property. 1/2 times the A, that acceleration, and 1/2 times the T. But we also have that T, and we already did this side of it to the left. So we're going to do this over here. So we have T squared now, 1/2 AT squared. Now let's think about that. Why do we have 2 times in there? We have 2 times because we're dealing with 2 units of velocities. We have 2 velocity units, so we need to have 2 time units. Time times time equals time squared. It's just that simple. Then we also have that. So this is a velocity statement. So technically in here we have 3 velocity statements. It's just a matter of how you look at it. But once we break it down, we're going to be stuck with V initial times time plus 1/2 of the acceleration times time squared. Don't forget that little squared up there. Now, remember, if you're starting with a 0 velocity, this unit right here is going to be 0. And all we're going to be dealing with is 1/2 AT squared. You're going to see this equation oftentimes with gravity and stuff like that. And we'll go into gravity to talk about that. So next thing we're going to do is going to take this equation right here again. Boom. We're going to take 1/2 A. You see what I mean? 1/2 of this. We're going to take equation here. 1/2 VF plus A VT on VI is equal to T. We're going to take that one and we're going to replace this T with a derivation of this T here. because t equals v2 minus v1 over acceleration. So we're going to take v2 minus v1 over acceleration, because remember, in order to solve for t or a, we're just going to put that back over there, going to multiply both sides by t, we'll have at, then we're going to divide both sides by a, we have v2 over minus v1 divided by a, we have v2 minus v1 divided by t. So we're going to take v2 minus v1 divided by a, and we're going to put that right here. Bow. You see that? Bow. Bow. So that t is going to become, now we're going to have 1/2 vf plus v1 times v2 minus v1, and that whole thing divided by a. That is a perfect square binomial. It's a negative perfect square binomial. So it's going to leave us with vf squared plus v minus v1 squared divided by acceleration. Boom. So that's going to bring us over here. Vf plus vi times vf, it's supposed to be a minus right there, forgive me, minus vi, because that's supposed to be minus vi from that one, divided by a. So that's going to cancel out and going to bring us to here, 1/2 vf squared minus vi squared over a. So then we're going to have that still is going to be equal to d. So now we're still trying to solve for what? We want to reorganize this equation, because right now we have it in a perfect way. We can solve wherever we want. But we want to get this to be a better equation to be able to solve for velocity at the end, final velocity. And that unit is going to be easy to do. So what we're going to do is have this d over here, and we have this 1/2. So we're going to multiply both sides by 2. So now we're going to have 2d is equal to velocity final squared minus velocity initial squared divided by acceleration. Now we're going to multiply both sides by acceleration. Boom. So we're going to have acceleration times 2d, or 2 acceleration d, 2 times acceleration in distance, however you want to word it, but it's 2ad. Get used to seeing that in your equations, and you're going to have that equivalent to vf squared minus vi squared. All we're going to do is do what? Subtract that now, or add the opposite. It doesn't matter which one you're solving for. If you want to solve for vf or if you want to solve for vi, it doesn't matter. But right here, we're going to add vi on this side, and we're going to add vi the other side, and that's how we get vf squared is equal to vi squared plus 2ad.